screen. Thanks for sending me the I haven't looked at it yet.
It's okay.
But thanks for sending
it. I think I have a computational argument I have to write out.
Okay.
I think if I take a note and split it, make it two halves, and like toast almost, I think I force the global minimums, and I think that'll work.
Yeah.
I think that's the core, like the symmetry argument.
The symmetry thing, yeah. But thanks. I just haven't looked at it, but I'm looking forward to looking.
Well, it's probably wrong.
No, it's good. It's like it's fun, right? So.
Yeah.
Yeah, sure. Hello, everyone. Let's get started. So today we have our exam. That'll be during the second half of today. Okay, and during the first half, I'm gonna have a topic, an easy one, a fun, right? We'll go back to stable diffusion next week. All right, so because we have to look at a lot of that in little pieces. So I've been preparing some of that for next week, and then you'll have a homework assignment related to stable diffusion where you have to train. You have to find a data set of color images, and you have to put in just a word and generate an image based on that. So, but yeah, we'll come back to that next week. Since today we have an hour and 20 minutes to look at something, I figured I would introduce a library, a nice little library. So we'll do that today. It's a very powerful library. As you know, we're in this second half of the semester, now focusing on images, right? And the algorithm is stable diffusion, essentially the generative type of things, or which is similar to GANs and things like that. So that's similar ideas, just different algorithms. Okay, so because of that, I'm going to introduce a famous transfer learning library called FastAI. So maybe you've used it, maybe you haven't, but it's definitely something that you should have in your toolkit. It's extremely powerful. So if you ever thought of training a classifier, right, for images, and maybe you've tried that already. Well, with something like FastAI, that's a solved problem. Do you see that? So think about that, right? So before FastAI, before transfer learning, it was always a challenge to build a good classifier for image classification. Now it is essentially something that's solved. So think about that. So whenever you're doing image classification, this is the approach that you want to take. Use the pre-trained model. So that's what I'll demo today. I just have a series of this library and some scripts, and we'll go through it, and you'll have this tool to work on. Maybe I'll create a homework with it. I'm not sure yet. And also, I will say I did create. Maybe you've seen this already on Brightspace, the project description. I had given this to you, but now I've officially put it on here, and I created the. Essentially the link. So I usually put it here in this module, because that way you're submitting your term project and you also fill out the forms for the course, the 8-bit questions and all that. But here's the term project, so I'll click on it. Same thing I had said before. The term project is open-ended. You should work in groups of 2. You can select any topic as long as it relates to the course. The project should use transfer learning. That's key, right? So you got to do transfer learning and deep learning, of course, right? So, which if you're using transfer learning, you are using deep learning. You will need to use PyTorch to train a model that performs some kind of task. You need to measure performance, of course, and you will present your results during the week before finals. You need to provide your code and submit a report. Please submit an email by April 8th indicating to me who is in your group and what topic you will be working on for the term project. Make it interesting, right? So any questions about this? So it should be something that you've always wanted to do, right? So have fun with it, and then you can work with a partner. Yeah, please. Yeah, I want to keep it groups of 2, I think. So not more than that. If you can't find a partner or something like that, we can talk about it, but definitely not groups of 4, right? Or 5. or that whole group or this whole group, right? So it's the smaller. Pardon? Yeah. No, believe me, I think one time there was one group that wanted 7 people in it. So anyway, so we'll start with so that's the project, right? Are there any questions about it? Pretty straightforward, right? Fun. All right, so let's go back to table of contents. The other thing I was going to say, I am offering a new course next semester. It's called Cybersecurity and Machine Learning. So it's going to be all cybersecurity. It's using cybersecurity for defense, but also the cybersecurity of AI. You see how it's 2 things, right? So for instance, adversarial machine learning, right? So how do you do that, right? So that relates to AI and the security of it, but also just how to build an intrusion detection system. You know what I mean? So, and there's more things there, information theory and things like that. So if you're interested, it's ITS 620. I can send you the syllabus if you want to look at it beforehand. It would be at night. I believe it's on Thursday nights. I always have the night shift. So, yeah, sir.
With
Pardon?
Companies, like how to protect private data when using AI.
Well, there's one of the examples is actually a privacy preserving algorithm. How you would do that, and it's actually based on the autoencoder. So I give you an example of how that would work. Yeah. But yeah, go ahead.
I say that's a white hot field right now. So I just did CompTIA's got a new cert I just took yesterday.
Oh, really?
Specifically, it's Sec AI Plus. So
Okay, great. Yeah.
it's hot right now.
Well, hopefully the class runs, it fills up, right? So, yeah, so if interested, you can send me an email if you want to see the syllabus, or, like I said, it's next semester, ITS 620, Cybersecurity and Machine Learning. Yeah, go ahead.
Is it like, in the Master of Applied AI, what kind of subject it is?
This would be an elective, so it's not part of a requirement. So these are elective courses, yeah. Like I think even 530 is an elective, maybe. I'm not sure, but definitely this one is an elective. So we have several electives. All right, yeah. So if interested, all right, guys, let's get to FastAI then. So we are essentially here, right here, and like I said, I'll continue with Stable Diffusion for the rest of the semester because that's a very big topic. So it'll take us a while to look at every single part, guys. But today I figure since we have the exam, we should do something light, but also very powerful, as you will see. Okay, so if we just click on this, this doesn't require theory because this is really we're just learning how to use this library. Just like with Hugging Face, it's more about understanding the workflow, right? So I forget the name of Jeremy something is the name of the person that created FastAI. He's a very famous person, but I forget his name right now. And some people will say, like when you go to a job interview, they'll ask you, do you know how to use FastAI? That'll be like a thing. It's like people don't want you, honestly, to do things from scratch, right? So FastAI, these are very useful libraries. All right, so let's go ahead. I have just a simple set of examples. So the goal today is really to understand how the workflow is, how Jeremy created these ideas, okay? So like with Hugging Face, it's more like, it's strict, restricted, so you have to kind of take your data or whatever it is and put it in the format that they want. So today we're mostly we are going to do training, fine-tuning with some data, but it's from the libraries. Later on, in a future class, I'll show you guys how to take your own data and put it in the format and train. Mostly FastAI, when I think of FastAI, because when I think of language, I think of Hugging Face, right? So when I'm thinking of FastAI, it's usually images, but you can do other things with it, okay? So I'll demo some of these briefly, but we'll start with the main example, which is images. And we will need Colab and GPUs for this because, we are training with a lot of data. So the idea is, and I haven't mentioned this, but I'll mention this later on, So we all know what CNNs are, right? So we covered those in 520, I believe. And so people over time, let's imagine over a decade of time, they invented concepts like what is a residual net, right? We've talked about this a little bit in the context of LLMs, right? So we have X goes through F, right? And then we get a Y, but we still add back the original X to the tensor. So we got two tensors with equal dimensions, and that goes through. So we're going to be using these systems called ResNets, which use residual connections, right? But think of it historically like this. People started building CNNs with 5 layers. As you got deeper, we have to add residual connections. Otherwise, we have what problem? The vanishing gradients problem, right? So if you go to a job interview, they'll ask you this question. If you don't know it, they're not going to give you the job, right? It's a fundamental question. You know, the depth of the neural network, especially here with a ResNet, which has 50 layers, right? You know, the thing that solved that problem was like these residual connections, okay? So adding back that X. And so that's where the name comes from, the ResNet. It became a very famous technique, all right? But essentially, it's just CNNs with residual connections. As time permits, we can look at one from scratch even. But you have to be aware that the ResNet has, 18 layers. There's a ResNet 50, a ResNet 34. That's essentially, a good 15, 20 CNN layers, followed by feed-forward layers with residual connections in between. Do you guys see that? And this architecture wasn't really invented by just one person. It was something that I would say between 5 and 10 years of competition. Somebody would go in, and then there's this problem, and then somebody solves it. So that essentially now we have this architecture, the ResNet 34, the ResNet 50, okay? And so once they arrived at that ResNet as it is in terms of architecture, everyone just started training it with more data. More data. They solve the problems, more data, okay? And so you essentially say, okay, that we have a ResNet 34, a ResNet 50. They were trained with 10 million images or 100 million images. Remember, that can only be done but like Google, Meta, etc. And so then you no longer have to train it from scratch. You just now get that ResNet. So it's the same concept as GPT-2, GPT-3, Llama 3, whatever it is, right? Except that now we bring in this CNN-based, very deep neural network with lots of residual connections, which has been pre-trained on a massive amount of images, possibly on 1,000 classes, which was the original ImageNet challenge, right? So 1,000 classes. And so you can, this network is really good at just understanding shapes. That's the best intuition that you can think. It can find squares, circles, shades, things like that. So then here actually is very intuitive to understand transfer learning. The first few layers are just really understanding general concepts of the image, like fur or not fur or branches or something like that. And then in the last few layers, usually in the feed-forward layers, is where you actually do your fine-tuning on your own data set. It's really good at getting circles, shapes, etc., and then boom, you have a problem that's very specific to you about, clothing and just understanding different styles of clothing. Do you see that? Or something like that. So that's a classic example. So the ResNet 50, pre-trained by somebody with massive amounts of data for more of a general task. You bring it into your own environment, and now you fine-tune it with your own data set for your specific task. It's going to be a really good classifier, and that's the thing that's the approach you want to take instead of just training a CNN with 4 layers from scratch. Does that make sense, guys? So that's the idea, and then of course, this Jeremy Howard, I think is his name. So Jeremy Howard, I believe, he created FastAI. This has been around for a few years. I would say 10 years or so. And essentially the same idea. So we just need a framework that brings in pre-trained ResNets, and then I load my data, and I fine-tune it, and then I have this powerful classifier. And he also wanted it to be done in very few lines of code very efficiently. So everything is, he's got functions for like grabbing the data and processing it, you know, the labels and processing them, or you can create your own, okay? So that's what we're gonna learn about today, is this simple template. So the first example that I have, Intro FastAI, it's some image problem. So let's go ahead and invoke Colab. And like I said, for this one, we will need a GPU because otherwise it takes a long time to train. Okay, so I'll start with CPU and then just switch. It doesn't take that many lines of code, but essentially, if you don't have the library, that's the one you need to install, FastAI. Okay, so here we go. And this example is of cats and dogs, you know, but we're bringing in a ResNet first. Okay, so import NumPy as NP. Just give it a minute. Then, of course, from FastAI vision.all, import all, essentially. And this provides functions for lots of things, even handling the data. It's all its own unique ecosystem, okay? It's meant to be to handle everything. All right. I mean, it's a very broad topic. He's got like a whole book on everything that you can do with it. Obviously, I'm only going to show you some of these things, and then you can dig in if you want. All right, so FastAI Vision, yeah, there it is. Okay, so I have it. This is going to be the data set that I'm using. This function here, on tar data, this is a native FastAI function. Okay, so it's a function within it, and it uses from urls.pets. So this is a pets data set, cats and dogs essentially, and the way that we can tell, there's like, you know, I think if the first letter of the dog breed is like lowercase, then I believe it's a cat. And if it's uppercase, it's a dog. So this is kind of how we can tell, one of the ways that we can assign the labels. So the function that you'll see is kind of strange, but it's because it's specific to that data set. All right, so let's run it. Let's give it a minute. Alright, so yep, there it is. Okay, so this function, as you can see, this is the function that handles the labeled. So some of these are very specific, but the idea is you create these functions and then like, you know, add them to this object, right? So you're creating this object, FastAI, that's going to handle everything. So the file name goes in, and then from there, if is upper, right? So the first letter is upper, then it's going to return true or false. And that's how we tell the label. Does this make sense? Again, not every data set is like this. They're specific. What's important actually is to understand where you put this function in when you're configuring everything. All right, so this is, you know, is cat, is dog. And this is actually the magic right here, okay? So these three items are essentially what Jeremy, I guess, invented or conceived to, like this is his workflow, essentially. One is for the data and how you handle the data. One is for the model, and then one is the command to do the training. Do you see that? So this is what you have to learn this workflow. Essentially, you have to understand how you craft things for FastAI. All right, so in this case, you can see here, this is an image data loaders. He's going to have multiple kinds of data loaders for text, for these other kinds of things. And so this one is from name function, for instance. Okay, so let's create this one. It's called a DLS. All right, so you specify path. Path is the data. Okay, so we got the data. Get image files from path. Okay, so this is a built-in function in FastAI. Okay, because we imported everything, right? So from there, this will handle bringing in the images, some kind of a seed, validation. The function that gets the labels, this one needs to be specific. But he's got this idea, right? So he's doing all the pre-processing for you, okay? This is why in a future class, I will actually take, like if you had a data set in a folder, how do you bring in your own data set into FastAI? Got it? So actually the learning curve is this, okay? So, once you have a different data set, you have to think about, okay, how do I load it into here? All right? So the best way that I can show you this right now is I'll just give you several examples so you can see the contrast, okay? But essentially it's a listing of the path, something that handles how to bring in the files, get image files. You can see that there. So that's a built-in function. This one is actually how you get the labels, and notice this is a function you define, is cat, right, and expects true or false. And then you have item transforms. So this is a PyTorch thing. Underneath is PyTorch, right? So just like Hugging Face underneath was PyTorch or TensorFlow, it's the same here. Okay, so these are this idea of encapsulation, right? So or abstraction. So they're just creating classes that underneath are using PyTorch. And so here the transform that's being used is the resize. This is key. All right, why that's necessary. The ResNet that you use expects images that are 224 by 224. That is like how it was trained. So if you have bigger images than that, they always have to be converted to the size. And this actually works. So remember that you can't really train, even today, you can't really train a ResNet 50 with like 4K or 8K images. That's just way too much, right? Imagine how big that would be. So we're talking literally about 50 layers of CNNs and stuff like that. So the images have to be resized to something like 224 by 224. Got it? And it works. It works really well, actually. All right, so that defines the data set, DLS. Okay, so now essentially we have this data set of cats and dogs, and we have all the information that we need. Like I said, later on, as usual, right? The data set is always complicated to get it into the specific format, but this is just our first example. All right, now that I have this DLS, then now I can go in and talk about the model. So FastAI has this set of functions, and they call them learners. All right, so it's going to have like text learners, it's going to have generic learners, collaborative filtering learners. In this case, guess what this one is called? It's a CNN learner, right? So it implies that we have something with relation to images, with relation to CNNs. Does this make sense, guys? And we are going to instantiate it and call it learn. Now, here's the magic. We're bringing in there a train ResNet 34. Do you guys see that? So this is literally a ResNet with 34 layers. If that's too big for your computer for whatever reason, go with a 16. It's going to be smaller footprint. There is ResNet 50. I believe it goes even higher than that. So, and it's just, I don't know in terms of the parameters. It's something you can look up. But they're not as big as LLMs, I don't think, but they're still pretty big. What is it underneath, as I said? Just CNNs. But they have residual connections, right, that we've talked about. Questions? So you can see we give it the data, we give it the ResNet that we want, some kind of a metric like error rate here, and we instantiate it. And so this ResNet 34 is already pre-trained. It was pre-trained on maybe 10 million images, right? So generic images. So it brings in a set of weights, it already understands shapes, forms, things like that. And what we're going to do now is we're going to use our data set of cats and dogs, right? And we're going to fine-tune this one. So it's transfer learning in the same context, but handled by FastAI. And this is for the classification problem. So these are not generative models, of course. Got it? So with Stable Diffusion, we're kind of addressing that more generative idea. All right, so I've created the learn. Now this part here, I do need to switch to the GPU now. And this is how you do the train. So just like in, I think in Hugging Face, right? It was train.train or something like that. Here it's learn.fine-tune. And by the way, you can, you know, with a simple flag, you could train the models from scratch. You could just say, randomize all the weights and let's start again. But obviously that's, you've learned hopefully with that transfer learning is going to be better. But there will be cases, there's one example I think, where it's just a simple RNN, so you guys can, hello, how are you? One simple RNN, so you guys can train it from scratch as well with this approach. Got it? And I think that instead of fine-tune, it'll say something like train once or something like that. So you'll see. All right, so now let's switch to the GPU because this part, and that's it. I mean, like, that's essentially the whole pipeline to train a very powerful image classifier. If you're ever doing a project and they give you a camera and you're supposed to do this is start here, right? This is the most powerful tool that you'll have. So let's go ahead and switch the runtime to GPU. Okay. All right, so now let's go ahead and run it. Okay. Oh yeah, go ahead please.
Here we are not deciding which ResNet 34 we are using. Is there like...
There's like a default one, yeah, like, yeah, so it's whatever he's made available in his, like I think even in Hugging Face Transformers, you could just say GPT and it would just like give you whatever the default one is at the hub. So I'm sure he's got his own hub.
So this is similar to Hugging Face?
Oh yeah, it's very similar to Hugging Face. These are kind of like startups. I think he's more like on the academic side, but yeah, he was actually a little bit like first, honestly. And but yeah, it's like that. So there's a set of models that you can bring in. You could change that to ResNet 50, and then as far as user, I don't know if he's got that implemented yet. But it's something to explore. All right, so we've got the libraries. Now we do the data. We're running on the GPU now. Give it a minute. Okay. Then remember to get the label. We instantiate the data set with everything, the transforms, instantiate the CNN learner with a ResNet 34, and now we fine-tune. And you can see there, so this is now taking those pre-trained weights, maybe 10 million images were used for pre-training, and now we're just using this data set for fine-tuning. One of the examples I have later, like I said, is where you can load your own data set. So that's a common problem, you'll encounter probably in data science, and so this is the approach that you should take. All right, so you can see it's doing one, by the way. You specify here the number of fine-tuning steps. So yeah, so this is definitely much faster Still, right? It's not. It's taking a while because this is massive, right? So that's what you have to like think about. This is, a ResNet 34 is a pretty big. All right, so I think. And I think it's done, right? So now, guess what? Now you have taken a pre-trained model, you fine-tuned it with your data, you're done. And so now you can use it. So I have several like use cases here to try things out. I need this widget. Yeah, this one. So this is just so I can grab some image. I may need to install the library again. Yeah. All right, so let's just install the library. Right, so that finished. All right. All right, here we are. So that should work. I think it's lowercase l. Yeah. All right, so this is just an uploader, just a little trick so that we can load any image. So let's load an image, uploader. So then you can pick an image. I have an image picture of me. Okay, and then sorry, I have it kind of in disorder. And so I've got the image in uploader, essentially. So I need to grab it from there and make it into an IMG. Okay, so from uploader, I'm going to grab the element, pill image, creates IMG. Yeah, so there's the image. And so now, guess what? You grab any random image, right? It wasn't like from the library. I just grabbed some random image from my desktop, right? And what am I going to do? I'm going to predict on it. So you can see I grab learn.predict, and now I can do my inference, give it the image, and it's going to tell me if it's a cat or a dog. So we just print the results. Apparently I'm a cat. Right? So, but that's the idea. Do you guys see that? All right, so obviously the data set is about cats and dogs. So now let's look at some cats and dogs. But you can see what's really nice about this is, it handles any image of any size. It's going to resize it. It's going to put it in the format that you want. So that's actually pretty nice. Now let's evaluate it on our own data set. So let's go back here to basics. So I did this one. Yeah, is cat. So let's take a look at that one. So I won't retrain the model again. All of this is done, right? The fine tuning, guys over there, guys. All right, so train the model. Now I want to see some images, for instance. So I need to grab them from, these images are in Colab, so I need to know the extension of it. So it's got even FastAI has even like OS type of functions to help you out with the computer, right? So in this case, I'm doing an LS, but it's an LS essentially in terms of FastAI, and I'm printing here where all the images are located. Essentially, what I needed was this path, right? So something like root FastAI, and then some image there. Okay, so let's copy that path. Just like that. So I can use this to pug. So pug is probably what? A dog, right? So pugs are dogs. So what do we do now? And this is pretty big. So you can see these are all the images in there. Yeah, this is your fine-tuning data set, right? Not the pre-training one, the fine-tuning. So usually what we've learned about transfer learning, the pre-training was massive, the fine-tuning not as big. Something that we can handle with one GPU, as you just saw. All right, so a lot of images. So you can see this is needs to be efficient for something so massive as this. Okay, here we go. All right, so just going to grab this one and change the path. So my image, so I'm going to change, I was using my home computer on this one. So let's change it. All right, so boxer, it's also a dog, whether it's pug or, okay, so I bring in the file. As you saw, you want to make it into an image, an actual proper image, so we can use pill for that. Pill image create, and this is probably also the FastAI version of it. Everything, they always make it their own version. So you can see that there. And now I can view the image just so that we can corroborate. So that is a boxer. Should be a dog, right? And so what we want is we want the model to say that it is in fact a dog. So because this is only for cats and dogs, so we learn.predict on image, okay, and then we print the is cat false. So you can see it is recognizing that this is not a cat. All right, now we repeat the same exercise, but with a cat. So I just have to change the right, so I just have to change the path again. Here's an example, and something called an Abyssinian. All right. Okay, just like that. Let's load it from the library. Again, we want to create it into an image. Come on. Okay, this is, let's call it second IMG. Okay, and now we make it into the image. We can view the image, and you can see it's a cat, right? And so now we're going to predict on this image, and let's see what it says. Okay, so we've done our prediction. And true. So it does say that it is a cat. Do you guys see that? So that's, the classic example of image classification with transfer learning, and you're using here a ResNet 34, an extremely powerful thing. So can you do this with PyTorch? Sure. PyTorch has something called a PyTorch hub, and so using that, so like a little library, you can bring in ResNets as well. But the problem possibly, or maybe this is how you like to do things, you'll have to code more, right? Because you're doing a lot of things there, and although the hub will abstract some things, so it's just another approach. This one is just, like I said, a code wrapper, a whole library called FastAI that does this for you. Yeah, go ahead, please.
I have I have two questions.
Okay.
First, what would have happened if we didn't fine-tune the model? Would it still have gotten the dog and the cat? It's like the base model, what does it do?
So you're forgetting a key thing, a key feature of transfer learning, the head. Do you remember the head? Right. So this was standard approach in Hugging Face transformers, and it's standard approach here. You have a CNN that was trained on a different task. Perhaps it did take images that were 224 by 224, but the heads in the end were not the same as this. You had essentially 2, 3 forward layers, and then the last one was it's a classification, so a softmax vector of maybe 1,000 classes, where it was learning bird, bus, car. Just go back. A lot of this goes back to ImageNet. So in 2012, there was this competition, ImageNet, where there's 1 million images back then, and that was amazing. 1,000 classes. This is the moment when Jeffrey Hinton and his team, Ilya Sutskever, Alexander, forget his name, but they created a 2-layer, I think, CNN, and they won. And it was essentially that architecture. Images go in on GPUs, 2, 3 CNN layers, and the head with a softmax output of 1,000 classes. You train on that. ResNet 34 the same. But then, what does the library do? It removes those last few feet forward layers. It removes that 1,000 vector, right, of 1,000 classes. That's the term there is removing the head, and the library will do what? Plug in a new head. What head is it using here? We can actually see it because it's right there. It's a 2-class problem, but all the weights remain from 0 to, let's say, 34. And then there's 2 or 3 feed forward layers usually, and then that head for the class that's being predicted. Does that make sense? This is standard approach.
That was my second question.
Okay.
That head that we are, the head is where we are fine-tuning?
The head is, so the library has to plug in that head based on the data set. Yes, so this is a data set of cats and dogs, right? So when we set up this here, right, with this label function, it's going to calculate for you the number of classes, and then it allocates the head that is going to attach to it. So it handles it internally. Pretty much like Hugging Face handles it for you. If you remember, we never really defined the head in Hugging Face transformers. Well, how did we handle that? I don't know if you noticed, but every time I would import something, I was doing import for sequence classification, or input for this type of, inference or whatever. So they just create, in a library, 10 functions. And each function essentially represents the type of head that you're going to add to your model. Do you see that? But yeah, this is how you do it. Because you have to train on some task, right? So you have to have a complete neural network. So let's say you give it 50 million images on a 1,000 class problem. That makes sense. Images go in, and it predicts which of the 1,000 classes it is. But the point is, in those first 34 layers is learning circles, triangles, squares, shapes of this or that. Yes, go ahead.
Sorry, this is a stupid question, but does that mean that like the classes that do dog and cat have to be classes that were in ResNet, or could they be totally?
Not necessarily. No,
Okay.
They don't have to be. That's a good question. Spaceships and meteors, you could do that.
Okay.
It's not a
As long
problem.
as your fine-tuning data had those in them.
No, you don't have to have it.
Okay.
That's the whole point. So let's go to the. I didn't connect my whiteboard, but let's do it here on this whiteboard. So,
Simply because it has the basic shapes.
yeah, it just learned. It's intelligent, so it figured it out. That's the whole point, right? It's a this is where deep learning scares you, right? So how did it do that? Because it's amazing. You know what I mean? That's the whole point. So an image comes in, which has to be 224 by 224. A ResNet 34 has, think of it as, these are CNN, convolutional layers. Very deep, right? 34. Imagine the amount of weights that you have. ... CNN, and then you have the feed forward layers. Feed forward layers. And then here, you have your softmax for a classification. And this, I'm using ImageNet as an example. This had 1,000 classes, like bird, bus, dog. But it did not have F16. You know what I mean? It didn't have stuff like that. Does that make sense? But then, what do you do what we're doing now? Because it had dog, in our example actually, but it didn't have pug or Abyssinian or whatever that cat was, or Doberman. That was not in there. So, but it still works because you come in, you leave this, right? So you want to leave this train, right? So we talked about the two strategies for fine-tuning. Either a very tiny learning rate, very tiny, or you freeze these and just fine-tune these, right? So essentially then, what you do in our example, you just have that. You add this head. This is just a matrix multiplication. It's super easy. With a softmax, 2 neurons, and then you're giving it, so the picture of the dog goes in, the CNN will do its thing. And then when this comes here, it's just going to predict one of these, and obviously you have the real data, right? And that's where the feedback goes to fine-tune the model. Does that make sense? Yeah. And does that make sense? And that's the head change. Yeah, go ahead.
The last head,
Mhm.
we are overriding it, or we are creating a new one?
I overriding, like I didn't answer it. I'm asking. So you said overriding.
Yeah. Like,
So I think it's a matrix multiplication from here, a set of weights, and this is like abstract, right? It doesn't actually exist. It's just, and then linear is just W times X plus B. So this exists, the last layer that you keep, right? Let's say that this is 1,000 or 2048, the feed forwards for whatever reason, right? So that means that from 2048 times W, this one. But you define what this one is going to be. So you just say 2. remember, so the intuition is that here it learns how to find circles. Maybe here it learns how to find triangles, squares. And then now squares and triangles, it starts to connect into creating more and more like shapes. It finds shadows. It finds angles. You know, if it's finding a lot of square angles, right, that's not nature. That's like more human-made versus things that are more nature and so like that. Do you guys see that? And so, you know, animals probably are not square-shaped, right, so, or less so. The shadows are different somehow. Yeah, so this is actually like one of those aha moments, right? Before LLMs came, remember, everything happened here, right? 2012 was the moment, and that was the ImageNet competition. 100% images, no text whatsoever. So for 5 years, that was the dominant thing. RNNs were there kind of doing their thing. And then in 2017, we get transformers. But so, yeah. Got it, guys? Any other questions? Yeah, go ahead.
In our code, where do we choose which layers we freeze? Like, what if we
It's just done internally. Here, we don't do that. So the library just handles that. It's internal. I'm sure there's a parameter, so you can get in there more. There's like, if you go into FastAI, there is a section where you can code more internally of what's going on, and you have more access. But this is just like the easiest workflow to get going. Later, as I said, when I give you your own data set, we'll see a little bit of that, but that's still pretty high level. Yeah, so it's meant to be, people love this. I mean, like, people, because you can get this to work really well, and it's really easy to get going. All right, so hopefully, yeah, so those were great questions, right? So I'm glad you brought up the idea of the heads, because we had seen that already in large language models. But yeah, if you're ever building a classifier of images, this is definitely a really great approach, because it's going to be very successful, as it's a very fine-tuned model. All right, so that is this example, okay? And we have time. We have about 30 minutes. So in the other examples, I'm just going to show you other things that you can do. This was the main example with FastAI, just to kind of like, you can see what else is possible. But yeah, like I said, for images, definitely, it's really great. So I think I still have the GPU, so let's keep going. All right, so I have another example. I'm not going to spend too much time on it, but just to show you other things that you can do. So there's a basic pipeline here for image segmentation. Later on in the semester, I will show you something like this called YOLO, and YOLO is for anyone. Have you guys heard of YOLO? Yeah, it's like a very robust library for object detection. So whereas this one was image classification, that one is amazing for like finding objects in the air. So one time, I know we worked on a project where, for whatever reason, they were trying to find aircraft flying overhead, right? So, and it would just find the planes all the time. Like, it would put a bounding box around it. There's a whole logic of how to find coordinates and then put the bounding box around the object, and you can actually like take that little bounding box, whatever's in there, and so on. So in this example, this is something called the CamVid data set, this whole area of research, right, that I'm not really going to get into, but it essentially is about like object detection, but even more sophisticated. So instead of just like a bounding box, it like highlights, oh, this is a person. It's like, imagine there's a person and it's painted green. And now you know that's a person. A car is painted blue, and so on. So you have this contrast in the images. And so I'm just going to show this real quick. But, these might be good ideas for the term project, if anything. All right, so this is the CamVid data set. Again, let's just focus kind of on the workflow of FastAI. So same idea, on-target data, CamVid, camera videos, things like that. This is a tiny data set. Okay. Then same approach, we create the DLS first. This is what relates to the data set. Okay, so notice that what I was saying, right? Now there's a new function or a new module. This one is called segmentation data loaders. So it handles that type of data set. And that's how you handle different data sets, different heads. From label function, so we specify the path, batch size, how do you get the names of the files? So there's a function, get image files, right, from that path. How do you get the labels? Notice that Jeremy and his approach, he encodes the labels in some way, and then he's got functions for it. So here he's extracting them from the name. Okay, label function, and this is the labels, right? So he's getting that information. And then there's this thing about some code for the image segmentation. So there's another set of data here. So I'm just kind of using it as is, just to kind of demonstrate. And then notice here, this one's a little bit different. It's going to use, because of the research, remember this is based on a research paper, to solve this problem they used a unit. We've talked about the unit already, right? Stable diffusion uses a unit, right? So we've talked about it briefly, and we'll continue to explore that a little bit more this semester. But this is a type of architecture. At some point, I'll give you a lot of these. I have some notes on a lot of these models. There's VGGs, inception models, ResNets, units, so that you can get a better picture of them. But yeah, a unit learner, and notice you just provide the DLS, which is the data set, and you specify which model you want to use in this configuration of a unit. All right, so you click on that. All right. So now what do? We're going to use that data set to fine-tune that ResNet, right, for this type of problem. So how is it, you might ask, right, the heads? It's being handled internally because we're using this specific function. Okay, so that's the key idea. So you always have to find whatever your task is, and then figure out how your data, if you were trying to do this kind of segmentation, would fit in here. Same approach as Hugging Face transformers. Okay, so let's, you can see now in the pipeline, you now fine-tune this model. Got it? Oops, sorry. And there we go. It starts training on the GPU, so bit fast, doing the 8 iterations. Okay. All right, so it finished, and now I'm just going to show you like a showcase of this. This is what the learner learns to do on, like the test set. It learns to do that. So it grabs images and it tries to find objects in it. So for instance, these two are people riding their bikes, so pedestrians. So I think this is the type of problem for self-driving cars, right? So self-driving cars want to know if they're where the pedestrians are so that the car doesn't hit them. And so this is the kind of, so here's the real data, I think, and the predicted. So this is the target and the prediction. So you can see, for instance, obviously here, this is pretty good. But here, I think it missed the pedestrians. It did seem to find something that could be a car. Do you guys see that? So does this make sense? Yeah, so again, just real quick showing you, I'm not going to get into this type of segmentation or this problem, but just showing you things that you can do. All right. We still have some time, so let's do a couple more. And yeah, and that's it. That's essentially it. Basics. So I did the segmentation. We've done this one. Movie reviews. This is, we'll skip that. Yeah, sentiment classification maybe. Oh, so yeah, so the reason why I have this one here is, although as far as I usually think of FastAI as just images, because I'll do any language thing with Hugging Face. But FastAI, I think is mostly images, but it does have functionality for other types of problems. So here's an example of language. I think this one takes a long time to train, but let's try it. So you can see here torch, right, in the background from fastai.text.ol. Notice, so it's got a whole section for text. So we can try that one. And then notice here the data set is going to be the famous IMDb. Some of you, we used it this semester, right? That's for sentiment analysis. So notice once again, you pick the module that's appropriate for your task. So text data loaders from folder, you tell it that you're going to use the IMDb data set, and you create your DLS. So you download it. Give it a minute. All right, while it's doing that, we can then move on to this part. Notice here, because this is related to text, then we are going to use something called a text classifier learner. So it's like the thing for modeling, but related to text. We take the same idea, we take the DLS, we plug it in there, we're going to instantiate it. But notice here, what are we using there? An LSTM, which is essentially a RNN, right? So a recurrent neural network. So I only showed the simple RNN architecture last week, I think. LSTM would be, so it's supposed to be a better one for sure. So, but I'm not gonna get into that one. But yeah, you would build an LSTM and you put in some parameters like the metrics, etc. Notice it's taking a while.
This is now a language model, right?
What's that? Yeah, this is for text. Exactly. So this is an RNN. It's not an LLM. It's not a transformer. This is an actual, like the RNN we saw last week. So this wouldn't necessarily be a pre-trained model. You can bring in like from scratch models also. You have that capability. The AWD, I don't remember what it means. It could be that it's some beefy RNN, right, for text that is pre-trained. I can't remember. But I know for sure some models can be trained from scratch. You just say, it's usually like a flag. All right, so it's taking a while. So let's kind of take a look here. You can see you can fine-tune the model. And now you would use this data, right, the IMDb, to train the weights of the model. There's your learning rate that you can specify. So a lot of the variables and parameters are essentially default, but so you don't even have to set them, but you can if you want to. And so the idea then, you would give it, you can see here, I really do not like the movie The Matrix, right? So it related to IMDb. So this is a sentiment analysis kind of a thing. So I would say positive or negative. Does that make sense, guys? Yeah, so I'm sure, I mean, he's constantly updating it, so I'm sure he has probably added LLMs to this, but like I said, I think the other library is more dominant. Hugging Face. But yeah, for images, I think FastAI is pretty important. All right, so I guess it's taking a while because these are big data sets, but you can see this is what the training would look like, and then when we run it on this sentence, I really do not like the movie, so it actually says, I think it's saying that it's positive anyway, so probably incorrect, right? Any questions, guys? No questions? Yeah. All right, so today was just quick showcase of getting started with FastAI. So you have this tool. Definitely later on, and maybe next week, we'll take some time to look at how to load your own data and look at a few other features. Let's see what else we have before we'll take a 10-minute break, and then you guys can start the exam 2. But let's just look. We can look at the other examples without running them, because they might also take a long time. So here's an example of just tabular data, and you can see the same idea. Now you use FastAI tabular. So tabular data usually just means like what? Like Excel spreadsheets. Yeah. So whenever you have, let's say, samples of a plant, and you have the pressure gauge and the temperature and the whatever the flow rate, whatever those things are. So you would store that data there. So you would use a FastAI tabular. You can see this is a data set about like demographics or something like that. So you use, notice, tabular data sets. So you have to pick for the specific problem that you're trying to tackle. Then you can specify things. This is loading from a CSV. You can specify, different things, normalize, fill missing data. So it's got quite a bit of functionality. And then notice this one, right? You can see here, we invoke. So this is actually a good example, guys. So you can see a tabular learner, right, instead of a CNN learner. Notice we give it the data set, but there is no model here. Do you see that? So this is probably just a classic neural network model, okay? A regression type model. And you can see here, fit one cycle is actually the function. So here you can see I wrote no transfer learning here, just learn from scratch. So possibly that AWD LSTM must be some kind of a pre-trained LSTM. For text, it makes sense that it was trained on. It seems to be pretty big. I just don't remember. You can Google what AWD LSTM is. It might be a pre-trained model. But yeah, this differentiates. So fit one cycle to train from scratch. Got it? All right, and then maybe one more. Let's see. We did this one, right? So I guess movie reviews. So this is like collaborative filtering. It's another area of machine learning, collab, just for collaborative. So this is like when you do ratings and things like that, and recommender system. So we'll skip this one. But yeah, all right. So that's it for this quick introduction. Just wanted to take the time today to something simple. So I've introduced FastAI. You have a new library now, and essentially, I would say big areas. If you're doing some kind of image classification, this is definitely one of the tools you want to use. FastAI, YOLO, those are going to be very powerful. A very powerful combination. Okay. All right. So yeah. So next. So we'll end here with the first introduction to FastAI. There's a few other libraries I want to discuss, like Replicate is another nice one for generative things. But we'll come back to this one a little bit more, and then we'll just focus on the algorithms and other things that we have. And like I said, the focus is images as much as possible for the rest of the semester. All right, so next week, hopefully, we'll go back to Stable Diffusion and maybe some examples of this. All right, so I'll end the video here.